Welcome back, students. Now what we had left our numerical somewhere here. What were we doing? We were trying to find the series solution for a differential equation, and for this we had assumed that the solution y is equal to n goes from 0 to infinity cn x to the power n. So what we did is we found y dash and y double dash, and we substituted it in the given equation, and then we have been doing certain steps where we have changed the limits and all these things, limits of the starting point of the summation. So we were here. We took the first expression. We took the first series. Actually, because these are not just terms, these are all infinite series. We took it. We kept it as it is because it starts from n goes from 2. After that we came to the next one. This is going from 0, so we'll try to make it go from 2. For that, what we'll do is we'll look at the first two terms. When I put n is equal to 0, I got this. When I put n is equal to 1, I got this. And then when I put 2 and the remaining, that part I have included here. Now we come to the second one. Here we have one more. If I have to start from n is equal to 2, here it's n is equal to 1. So we can take one term outside the summation by putting n is equal to 1, and we got this term, and then we put the next that goes from 2 to infinity inside this. Then we come to this one. This one can be written as, the first term can be written as, when I put n is equal to 1 here, it becomes minus c1 minus 1 is equal to 0. We get c0, and x to the power 1 is x. So we get it this way, and the remaining I put inside the summation sign. So I have to put here a minus sign. So n goes from 2 to infinity cn minus 1 x to the power n, and this is equal to 0. Now students, what we do now is we collect all the terms. This obviously amounts to 2c2. This one comes to be, I think there should have been a 2 out here. Yeah, there should have been a 2 out here. So this is 6c3x. Then we have this one. We are collecting all the terms before which there is no summation sign. That means they are not series, they are independent terms. So, and the next one is plus c1x. And then we have another one, this one, minus c0x. So c0x. So you see, we have these, what was this one? c3x, and this is c1x, like this. So you see, we have 3 terms with x and 1 term without x. So this, in the next step, we can write this as, let us write at the top. That implies twice c2. Please compare with your copy, because I can't at the same time look at the bottom of the, show you the bottom of the board and the top also. Twice c2 plus minus c0 plus c1 plus 6c3 into x. These are the parts without a summation sign, like this. plus we have another one, plus we have the whole part within the summation going from n is equal to 2 to infinity. Because look at this, students. Let us look at this one. You see, we have this one going from n2 to infinity, this one going from 2 to infinity, and this one going from 2 to infinity, and then this one going from 2 to infinity. So we have collected all the others here. Of the others, this is without any x, this is with a x, this one with a x, and this one with a x. So that's what we do here, and we have taken this outside, and now we take all of them inside the bracket, and you will find that they are like this: n into n minus 1 cn plus n plus 2 into n plus 1 multiplied by cn plus 2. See, we have a multiplied by sign here, plus n multiplied by c, sorry, it should be like this, plus n into cn minus cn minus 1 to whole multiplied by x to the power n. You see, all of them have x to the power n here. See, all of them like this, which is equal to 0. So what we do is, let us now equate coefficients of equal powers of x. So when I say equal powers of x, I'll take some time to rub this, because if I clear this directly, the first equation written on the top will also be get erased, and I'll have to spend a lot of time in rubbing it, in writing it. So I'm just cleaning my board. I hope you are noting down everything, students. I hope you are not just sitting there, otherwise you'll fall asleep. And I tell you, one of these will come in your examination of about 5 marks, sometimes also 6 marks. So please do your series solution properly. And till we meet face to face, we have to go through this process. It's boring for you, and it's extremely difficult for us. The whole day, almost the whole day, is spent in recording your lectures. So okay, so this is like this, and which is equal to 0. So what we do now, equating coefficients of equal powers of x. So what are the powers of x here? X, we have x to the power 0, then x to the power 1. Look at x to the power 0. This first term is, we don't have a x, means it's x to the power 0. So on both sides which we equate, do we have any x to the power 0 on the right hand side? Obviously not. So what I write? I write that the coefficient twice c2 is equal to 0. Now c2 is not equal to 0. So 2 is not equal to 0. So c2 is obviously, that implies c2 is equal to 0. This is the first information we obtain about the c's. You see the whole process, if you go back to your power C solution, you'll find that the whole process is finished when we find the values of C0. Sometimes you'll not find the values, you'll just find a relation. Now, so let this be equal to A. Now let us go to comparing the next power of x, that is x to the power 1. So x to the power 1 is what? This one. And do we have this side? No, we don't. So what can I write? We write again minus C0, we don't need this bracket here, minus C0 plus C1 plus 6 C3 is equal to 0, which implies, what is C3? C3 is equal to 1 by 6 of C0 minus C1, which I can name this equation as B. So this is our B. So this is B like this, and let us move forward like this. We got C3. Again we have Cn plus 2. What is Cn plus 2? Cn plus 2 from that original equation is, let us see where is Cn plus 2. N plus 2 is, Cn plus 2 is, from here you can get it, because this is Cn plus 2. So from this relation we can find, because you are equating now the coefficients of x to the power n. When you equate the coefficients of x to the power n, like we equated the coefficient of x to the power 1 and x to the power 0, what we'll get is, we'll get something like this. Cn plus 2 is equal to Cn minus 1 minus n square into Cn divided by n plus 1 into n plus 2, and we call it, this we name it as A, and we call it the recurrence relation. Recurrence means that which comes again and again. So you see, when I put here n is equal to 0, I get C2. When I put n is equal to 1 here, I get C3, and things like this. So when I put n is equal to 3, I get C5. So let us do that now. Let us put n is equal to 2 and all these things here. So first let me clear my board and let me go to the top. I'm sure you must have noted down everything in your copy like this. So putting n is equal to 2. When I put n is equal to 2 in the recurrence relation, you will find that C4 is equal to C1 minus 4C2. See, at this point of time, you have to do certain things by yourself. Divided by 3 into 4. So I'll remind you that what was the recurrence relation. Recurrence relation was Cn plus 2 is equal to Cn minus 1 minus n square into Cn divided by n plus 1 into n plus 2, this one, which was the equation A. So I think I have to stop here again, and I have to wait for the next part to finish my numerical, see how long it is.